Hi, my name is Matthew Poes, and in today's episode we're going to talk about the home theater that I'm building. So I mentioned in the last house I had done a soundproof home theater, and it was really important for me to make that soundproof home theater as soundproof as possible. As I mentioned, a lot of this came from my desire to be able to listen to music and movies at pretty loud levels. I absolutely enjoy THX reference levels. I like to listen to music pretty loud. On the other hand, my wife tends to work in the evening. She really doesn't like loud noises. She's sort of the opposite of me in that regard. And so it was a struggle for us, for me to be able to find time to watch my movies and listen to music, and for her to be able to do what she likes to do, which is working in the evenings. And so we talked about it, and I think ultimately that was part of what motivated her to allow me to do the soundproof theater. And as I mentioned, I did it, and aspects of it were really good and aspects of it were not. Some of it was just circumstances. It was just kind of dumb luck that the place she most liked to work happened to be directly over the theater, and that there was a significant amount of sound energy and vibrations that were being transferred right above like that, causing things like furniture to shake. So in this theater, I actually want to take everything that I learned from that build and some other builds that I've done and combine that into the new build to make it as soundproof as possible. So one of the things that I really want to do, and I'm going to do some more videos on this where I'm going to delve into each of these topics more precisely to help people learn this, is that soundproofing, the way it's often discussed on forums, and the way that you see it presented often from the company selling products, is what I would call a sort of cookie cutter approach. Now, professionals that do home theater designs, or really, to be honest, it's not a very big business, so really soundproof commercial space design, recognize that when you're doing these soundproofing designs, you actually have to design each wall. So every wall within a room is different, and as a result of that, every wall within that room needs to be designed for its intended purpose. And that's not the same as the cookie cutter approach, which tends to be, the most common one we see anymore is wooden studs, 16-inch on-center spacing, little metal clips with hat channel clipped into it for decoupling purposes, and then 2 layers of drywall with green glue. Or the other one that's pretty common would be a single layer of drywall, regular wood studs, maybe the hat channel and metal clips as well, and what's called MLV or mass-loaded vinyl. And these approaches work fine. They're techniques that are usable. The issue is that how well they work really depends on what it is you're trying to achieve. And what you get from that wall, for instance, may be more than you need in some places, and actually may be costing you significant money and losing relatively significant floor space with no appreciable improvement in soundproofing. And in other cases, it may actually be totally inadequate. And so in the room that I'm doing, just circumstances, again, from the way that the room came together, have made it so that there is no 2 walls that are the same. Every single wall in that theater is a different kind of wall. And because of it being a different kind of wall, each wall needs to be engineered differently in order to meet what is essentially the same soundproofing standards that I need. Just quickly, I'll kind of go through those walls and try to explain how they're different and then how I'm designing them each. Now, I'm using the same basic materials in all the walls for the most part. I'm just using different amounts of them, or using them in different ways to achieve the results I'm trying to achieve. So in a home theater, you've got what's called a partition wall. So a partition wall is any wall in a house or a building that separates 2 rooms. It's an interior wall. Now, these are especially important in soundproofing because these are the walls that essentially not only partition rooms, but they partition sound. They're what separate sound from one room to another. And so, like in my case, I said I bothered my wife with my loud movies. So I need to think about these partition walls in terms of what's on the other side. So one of my partition walls has an office on the other side. It's in the upstairs area where the theater is. So there's kind of 2 ways to think about this one. On one hand, how often is somebody going to be working in that office while somebody's also in the theater listening to music? My guess is probably not all that often, but that was the issue before, right? So we need to make sure that the partition wall actually probably is pretty soundproof, because I want to make sure I don't bother my wife if she's working in the evenings there. So that partition wall is going to use a technique. So in the last one that I did do the hat channel, the isolation clips, the double green glue, And there was one partition wall that I used all that, and I also did a double stud wall, which has some benefit, but to be honest, I only did it because I had extra materials. It's pretty costly and it doesn't really offer a lot of benefit. So in this case, I'm going to do something similar, but I'm not going to bother with those clips and hat channel. I'm going to use a different product, which I'm going to introduce to you later, but it's basically 2 blocks of wood with a little silicone isolator between it, and it works basically the same as the hat channel does. Actually a little bit better, to be honest, and that's what's pretty cool about this product. It's relatively inexpensive for what it is, and so I'm going to be highlighting that a lot because it's going to be used throughout the build. That's essentially my decoupling, and I will explain in a future video about how soundproofing works and so why decoupling is so important. But I'll mention that decoupling really is probably the most important thing you'll do in soundproofing. It's more important than mass. So you hear people talk a lot about mass, and mass is important. It's a part of the equation, but for the most part, the majority of sound isolation that you get in your soundproof space is coming from that decoupling. The walls themselves actually have a relatively decent amount of mass in them. And so the decoupling is really what helps to stop a lot of the sound energy from transferring through. Adding mass makes it better. You will stop more sound, but it's not nearly as much as people would think. And in fact, just adding mass tends to be counterproductive. You'll add a whole bunch of mass. If you don't do anything to decouple, you're going to kind of hit a point where you actually go backwards, you regress, and you start letting more sound through. So it's not a great idea, and it's really expensive, and it makes the walls thick and heavy. So you really want to focus on the decoupling first, the adding mass second, and damping, which is what green glue is for, sort of a third tier thing. It's important, but actually of all the other things, it's probably the least important. It just depends on how much of a resonance is in your structure. Okay, so back to this partition wall. This partition wall is going to need to be pretty good, and to be that good, what I'm going to have to do is actually have 2 layers of drywall on both sides for a total of 4 layers of drywall. There's going to need to be some decoupling. We're going to decoupling actually only on one side, and the other side that won't be decoupled. That's because it's really not necessary. You don't see a lot of benefit from doing that. The decouplers work well enough that once you've decoupled the one side, there's no benefit to decoupling the other side as well. And this is based on lab testing that was done on this particular product that found that it worked so well that additional levels of decoupling offered little to no benefit, about 1 STC point, which isn't worth it. There's going to be insulation in the wall, but the most important thing is that even though I am decoupling with these, I'm actually going to do a double stud wall. So it's going to be like maximally decoupled basically. And the reason why I'm going to use these isolators and the double stud wall is that even if you isolate the double studs from the rest of the structure, and there's little devices you can get, little parts you can get for doing that, it's not perfect. And because it's not perfect, you can still have some sound transfer. So this is just a way of helping to improve. That's why I did it last time. Again, it's not a huge benefit. You're probably gaining about 1 or 2 STC points from doing this, but you add it in good places, which is why it tends to be worth it, and the cost isn't high. So that's going to be that partition wall. Now there's a second partition wall that goes out to the doorway that would go into, this is actually the doorway entrance into the theater has a partition wall. So there's a staircase that goes up to the theater and it goes to the office. That one doorway is going to need to be very soundproof. So I'm going to be putting a 350-pound soundproof door in there. The wall itself is going to need to be fairly soundproof too. So the target STC that I'm going for in these walls is around 60-65. I'd prefer higher, but that's the realistic level that I'm going to target. And so to do that, like I said, in the one partition wall, double stud wall, in this partition wall, actually, I'm also going to look to do a double stud wall, and I'm also going to do the decoupling on the one side. I'm going to do the 2 layers of drywall on both sides for a total of 4 layers of drywall. And I'm going to stick to a similar thickness. So the wall on the one side probably is going to be around 9 to 10 inches deep. This one will also be 9 to 10 inches deep. And that will provide a lot of internal transmission loss. Now, the 2 outside walls are the tricky ones because they're different. So one of the outside walls is a block wall. Now, cinder blocks provide a significant amount of sound isolation. The traditional way that houses are built in Florida for protection against hurricanes uses cinder blocks, but then there's a problem that comes about, and that is that they tend to use the 2x4 studs screwed directly into the cinder blocks. They spray in some foam, they put up the drywall, and they call it a day. It actually provides a pretty good amount of sound isolation, but for the purposes of soundproofing, it's not great because you kind of hit that point. It's around STC 40 to 45, and that's as high as it's going to go, and there's nothing you could do. You could add 10 layers of drywall. You're really not going to get a better wall out of it. You're just going to waste a lot of time. to really get better sound isolation, to really get a lot higher than that, then what you need to do is actually do a normal 2x4 stud wall that's separated out from the cinder block wall. So it's sort of a double stud wall then in a sense. In this case though, it's a cinder block and stud wall, and they're separated by about a 1-inch gap. So you've got the 8-inch thick cinder blocks. You've got about that 1-inch gap plus 4 inches for the 2x4s. So you're looking at about, it's not exactly 4 inches. You're probably looking at about 4.5, maybe 5 inches total of air gap in there. And of course you put insulation. All the walls are going to have insulation in them, a light amount of insulation though. You don't want to go too heavy. It can actually cause problems. And then there's going to be probably 1, maybe 2 layers of drywall. I actually still have to do some modeling on these to see what's necessary, but it really may not be needed to add the second layer. It may not offer any benefit to have that second layer with green glue. But again, there'll be decouplers on the stud wall that's there. The ceiling is going to be a similar kind of structure. There's going to be these decouplers. Now this will have 2 layers of drywall. That'll be necessary because there isn't going to be a lot of other stuff to provide sound isolation. You're going to have the rafters, and then you're going to have some decking. If I really wanted to go crazy, I could do 2 layers of decking and get extra sound isolation. But to be honest, there's so much airspace in that kind of attic area that it's not a major concern. So it's going to be all filled with insulation, and I'm not too worried. That should be fine. The 2 layers of drywall that are going to be up there, I'll actually probably have 2 layers of drywall for a bunch of it, but there may be probably plywood and drywall in another area, which makes it easier to mount the projector on the ceiling. So you have a layer of plywood, and then below that a layer of drywall, and then there's going to be green glue, which helps with damping. It's just a good idea. It also keeps it from getting too stiff. So when you glue, like with construction adhesive, 2 pieces of drywall together, that structure becomes 7 times stiffer than it was before. With green glue, maybe like 1.5, at most 2 times stiffer, because they tend to shear. They slip back and forth from that adhesive, which is how it works. As a result of that, when they bend like this, they tend to shear instead of sticking together, and so it doesn't get as stiff. In theory, a perfect constrained layer dampening structure would actually be no stiffer than the individual pieces are, but in practice that's not true. All right, so then we've got the other outside wall. Now because this other outside wall sits over an area for which there is no cinder blocks below it, I can't put cinder blocks there. I mean, the nice thing about cinder blocks is they block a lot of bass, so it's really good at keeping low frequencies out of the room and the other way around. I mean, it just keeps you from bothering people, which is going to be important. Unfortunately, I can't do that. And there's a risk in this particular case because this portion of the house will, this wall will kind of look over a large portion of the living space. And so the sound could re-radiate back into the house, and I don't want that to happen, especially at low frequencies. So now I have an exterior wall, and the exterior wall needs to be very soundproof. So the cinder block wall that I mentioned is going to have an STC of around 75, which is about as high as it gets. I mean, there's some people will talk about 80, 85 walls, but in practice, that's not a realistic number to hit. So 75 is pretty close to as high as you're going to get in a wall design, and I need to match that on the other wall. So I'm going to go back to the same strategy I was using on the others, but I'm going to do them thicker. So you're going to have on the outer wall a 2x6. On the 2x6, there's going to be an outer layer of sheathing, probably going to be plywood. And what I'm going to look at is possibly using hardy board instead of plywood, which is what's typically used. So there'd be 2 layers of hardy board then, screwed together, green glue between those, potentially. Then there's going to be a 2x4 stud wall. So it's a double stud wall, but it's a 2x6 and a 2x4. And there's going to be that 1-inch gap between them. There's going to be insulation in there, so we're looking at about a 10-inch thick wall there of air gap. And then on the other side, we're going to have, as I mentioned before, there's those decoupling devices that I'm going to be using, and then there's going to be 2 layers of drywall. Maybe 3 layers of drywall on this particular one, because this is one that needs to be blocking more sound. And to get to that STC 75 that I'm looking for on that wall, I'm going to have to take some extra effort. Now you might say, like, why wouldn't I do that for all of them? And the answer is, it would be harder to achieve that kind of level on some of those other walls, the interior partition walls. It's unnecessary, so it's kind of too much soundproofing, and it costs too much money. So I'd be giving up probably a foot of space on the floor on each side, so probably close to 2 feet in total in the room. That's a little crazy. And yeah, I might get up into the 70s by doing that, but it's just unnecessary. I mean, if I'm listening to music at, let's say, 100 decibels, basically the story I'm trying to tell here is it's just too much, it costs too much, it gives up too much floor space, it's not what I'm going to go with. But on that one wall, I am going to be giving up some floor space because I need to make sure that this thing is basically good enough to isolate and keep the sound out. The floor is probably the trickiest one, and this is going to be neat. Probably this is going to be one of the first times a floor like this has been installed. The concept is not new, but the materials that I'm using and the way that I'm using, as I understand it, was tested like maybe a month or two ago for the first time ever in order to get proper test data and a UL rating for it. So this particular one is going to have, you have your, not trusses, but the floor joists, there we go. So you have your floor joists, 16-inch on center often. These are standard, there's nothing special about them. I mean, they might be engineered, but beyond that, there's nothing special. You have a layer of decking put across that. So the next thing, what gets kind of unusual here is that instead of just having more layers of decking or green glue or something like that, there's actually going to be those same isolators that I'm using elsewhere. And so those are going to be adhered to the bottom of another layer of decking. And there's going to be very thin fiberglass insulation, like R7 or so, that's going to be stapled to the bottom of those pieces of plywood, and then those are going to be just floated on top of that first layer of decking. On top of that layer is going to be another layer of decking with green glue. So a total of 3 layers of decking, but between the first layer and then the other 2 layers, which are in that CLD sandwich, is going to be these decouplers. And so the total floor thickness is going to actually add on top of the joists probably about 2 inches to 3, probably closer to 3 inches actually. So it's, it's a pretty thick floor, and it's decoupled. And so, I would love to tell you that that's like an ST, so actually the IIC and STC rating is going to be something like 70 or 75. It's not. That crazy heroic effort that I've made there is actually only going to bring it up to about 60, 65. But I'm thinking that's going to be enough. What I can do on top of that is I can actually do a rubber mat, especially like a convoluted rubber mat, and then the flooring on top of that. And that will bring the IAC rating is probably going to be in the 50s, and so that'll help bring it up into the 60s. It might bring the STC up another couple of points because there's some mass there and some extra isolation. Beyond that, if I really wanted to make it even better, I would actually have to go down to the first floor and start doing some stuff to the drywall there, and that's going to not work for this room. So those are the kind of heroic efforts, if you will, that I'm putting into making this room soundproof. As I said, I'm targeting around an STC 75 on the outer walls, an STC 65 on the inner walls. The door is going to be an STC 45 to 50. When you see this, though, you'll understand that this is actually an exceptionally good door and that the number probably doesn't reflect what you're thinking. And it should be really quiet. And then the next thing that we'll have to talk about in another video that's going to be unusual, of course, is the air conditioning system is going to have some attention. I'm not going to go crazy here, but there's going to be some attention put to making sure it's quiet. And so it's going to be a separate system for that room compared to the rest of the house. It'll be shared with the office, that's about it. And then it'll have some effort made to muffle sound from transferring between it and other places, but actually more importantly, keeping air noise down, because I want the room itself to have a very low noise floor. I'm targeting somewhere between a 0 and 10 dB noise floor. I'd love it for it to be 0. That's really hard to achieve though. And the HVAC is the #1 thing that tends to screw that up. So when we get to that, I'll show you guys the things we're going to do to help ensure that that actually is possible. So that's the room from a soundproofing standpoint. From a design standpoint, I'm working on it. I'll show you guys some sketches when we get there. But for the most part, I'm just focusing on getting that soundproofing stuff done, because when we get to construction, I got to be able to do that. All right, well, I hope you enjoyed this. I got more coming. See you next time.